The threshold in Australia is ensuring that the fuel system performs under all conditions. If someone turns around and says, my Walbro fuel pump failed after 50,000 kilometers or 6 months, Walbro is made by TI Automotive. That's a $3.5 billion per annum company. All of these cars use Walbro fuel pumps. So people start blaming the fuel pumps, and workshops allow this to happen.
Is having 2 fuel pumps better than having 1?
It depends on the situation. I'll give you a scenario. Let's say you come to me with a supercharged Chevy SS. I get you to drop the base fuel pressure down to 40, and they want 600 horsepower at the wheel. It's going to stand unleaded, so not E85. With 40 psi base fuel pressure, 10 pounder boost, so 50 psi total fuel pressure, big alternator, I can get there on a single Walbro 460. But the problem is this: the supply to the engine should never be a 1-to-1 ratio. You want fuel coming back. It's more difficult to design an 850 horsepower fuel system than it is to design a 2500 to 3000 horsepower fuel system.
How? Welcome back to another episode of the Street Alpha Podcast. I am your host, Tukes. And today we are at Ripatuned again, but we are not interviewing Steve and Tony. We are interviewing Julian, who came all the way out from Australia with Aftermarket Industries. So let's clap it up for Julian. So you're the first guest that we've had on the podcast that is from another country, which is pretty cool. In Australia, of course, because that's one of the places I want to go to, who's known to have the fastest GTRs in the world. So you have worked with a lot of those cars and that platform in particular. You have an engineering background as well. Can we talk about how you actually got into engineering and how, you know, your background and how you developed the company that you have today?
Yeah, so I started off in law.
Law.
Yeah, so engineering was not on the, on the spectrum, or, it wasn't an idea. Everyone told me I should be a lawyer because obviously I like to argue with people.
You sit like one.
Went to uni, to study law, and then wanted to go in a direction, and that direction was, work for a top tier law firm. Sat down with the guidance counsellor at University of Technology, Sydney. I also lectured at the University of Technology, Sydney. I was one of the mentors there in the business faculty, so shout out to University of Technology, Sydney.
This is your camera.
Yep, that's my camera. And after I received some of that guidance in terms of what I needed to do in terms of my grades and obviously extracurricular activities to get into a top tier law firm, because they look at all those things, grades, law society membership and all that type of thing. The workload was just really heavy. I thought, look, I can't study and have a life outside of university. Right. I wanted to reward myself, and I'm sure people do this. And I said, look, what can I do to keep myself really focused on study and staying on the straight and narrow, so to speak? And I started building a race car. And back in those days, year 2000, 1999, the parts scene wasn't as developed.
Right.
So, there were intercooler kits, and obviously you could do turbo upgrades, and there were basic ECUs in the market at that point, but the fuel system side of things was just dead. There was nothing. So started to look for parts, couldn't find it, and then thought I'd sketch up my own parts, and downloaded some free, CAD software. And then one thing led to another, had some free electives within the law degree. Being an undergraduate law degree, you have a lot of free electives to try other things. And one of those subjects I took up was basically all the first year engineering subjects.
Okay.
And then steamrolled into the second year, and I wanted to take more subjects, and they wouldn't allow me, and made an application through the uni to enroll into the engineering degree. It became a law degree and engineering degree. And that's how it started.
Does law play a role in your career at all anymore?
It doesn't. So just to obviously keep that story short, I ended up working for a very large commercial law firm. Was there for about 3 years, worked in commercial litigation, worked in major projects. So a lot of the major infrastructure projects in Sydney, Cross-City Tunnel, things that you wouldn't know, Chatswood Interchange. I worked in the teams that wrote all those contracts. So it plays a role in terms of how risk averse I am with Aftermarket Industries, making sure that from an engineering perspective that the product isn't failing. You hear that a lot with our products. Oh, it's over-engineered. It's over-engineered because I've been on the litigation side of $200 million lawsuits of companies that haven't done the right thing, haven't engineered products well, whether it's software, whether it's business services, especially when I worked in the major projects infrastructure team. I dealt specifically with non-completion clauses and a lot of breach of contracts. So that plays a huge part in terms of how we structure, I guess, our design DNA, and making sure that what we do is, we're not just draftsmen drafting products. We run through CFD analysis, we run through simulation, we run through material strength test, impact load test, von Mises stress test, impact testing. So one of our surge tanks, and this is a fact, we stress tested the surge tank that it could take 400,000 newtons of impact. So it's about the same as being hit by 18 wheeler at 170 kilometers per hour, and it still won't fail. It'll deform, but it won't fail. So, and I remember in the beginning when I started the business, with that sort of mentality, over-engineer. I think people found that a little bit amusing, that's over-engineered. Why would you need to do that? And I have a good story. So in 2016 or 2017, Tristan Catford Racing, which is a real rally racing team in Australia, they were competing in a tarmac rally in Tasmania. I think they were in the final round, the final race of the season. They were about 20 seconds out from the finish line, and they obviously, it's a rally team, so that Tristan and his partner, I don't know his partner's name, they lost the brakes and they hit a tree at 170 kilometers, 160 kilometers per hour, or some ridiculous number, maybe 110, 120. Car was completely totaled, and that fuel system was exposed in the back. Didn't leak, didn't fail, and that's important.
Well, hold on, are they okay?
Yeah, they're okay. No.
The fuel system's okay, but
I care about the fuel system. Right. But look, they sustained the co-driver, which was his partner. She sustained a lot of injuries, broken ribs, I believe, and whatnot. Could have been some broken legs, but that could have been increased by,
if there was some type of
course, fuel leak.
Yeah, right.
And so I think people don't realize that. We do a lot of what we do now is we do a lot of engineering reports for the Australian government or organisations that have to pass compliance on fuel systems, and we have to give them reports, drawing specifications, what ISO standards we use for engineering, material grades, and you buy this stuff from. And I don't want to throw shade at China, because a lot of companies make parts in China, but if you're allowing third parties to engineer your products and you're just having your logos laser etched, then there's a break in the chain of, I guess, responsibility.
Right.
If you're selling that product, you better be sure that that product is going to last, or be not add to the injury in the instance that there's an accident. So that's always obviously front of mind with us. So yeah, that's a big differentiator in the way that I run the business, definitely.
So before we take a deep dive into the actual products that you actually sell, can we talk about what you actually do with the business? Sure. Because people probably may not know what you guys do with the company.
Sure. So Aftermarket Industries designs fuel systems for motorsport applications. So a lot of the focus now is plug and play systems. So we work with different platforms. So whether it's, GM, so Chevy SS, Camaro ZL1, Camaro SS, the CTSV, the Pontiac G8, now the Trackhawk with the guys here at Ripper Tuned. We'll be releasing the Mustang kit shortly as well. And we obviously do a lot of universal products as well. So surge tanks, fuel pump hangers. We do have, I want to say comfortably, we have probably the largest range of, in terms of different products and products that are modular. Right. We have the largest range of fuel pump hangers and surge tanks and fuel tanks on the planet. I'm comfortable saying that. I think we have 9 different fuel pump hangers, for different applications, whether it's time attack, drifting, street, track racing, circuit racing. So we have universal products, and we also have plug and play systems. And when I say plug and play, drop it into the fuel pump, into the fuel tank. Right. It comes with fuel lines, comes with mil-spec wiring. So that's a big part of the focus. But yeah, so fuel systems. Yeah, fuel pump hangers, surge tanks, fuel tanks.
So I every time we speak, I normally hear the surge tank come up often. Yes. So can you explain what that is for people who don't know?
It's a reservoir that's always full.
Okay.
And that becomes the primary supply channel to your engine, your injectors.
Right.
And everything channels through this. So your fuel pump inside your fuel tank goes to the surge tank. The engine, the injectors return back to the surge tank. So this reservoir is always full. And the reason why that's important is when you're under load, when you're accelerating, you're cornering, you're braking, you have that fuel supply available. So the biggest issue with a fuel system is making sure that you don't have surge. So really, it's not a surge tank; it's an anti-surge tank. But we just know it as a surge tank. So, but technically, it's an anti-surge tank. So anytime you find a flat spot, when you're accelerating and you don't have fuel, that's surge. That's fuel surge.
Okay. So is it similar to something like a dry sump? When it comes to oil?
For oil, yeah, very similar.
Very similar.
Very
so
similar.
When you're under load, like you said.
Yep.
Now, one thing that we spoke about before also was a lot of these record passes that are made at the track, if those cars are on a full tank of gas. Can you explain why it's important to have this and what role it plays in that?
Sure. So in Australia, things are a little bit different because we're so... look, America's great at XYZ and Australia's great at XYZ. We all have our strengths and weaknesses. In Australia, the fuel system side of things from a build perspective is quite mature. The status quo or the threshold in Australia is ensuring that the fuel system performs under all conditions.
Okay.
And what that means is we want to make sure when we design a fuel system, even a drop-in system for, let's say, a Trackhawk, we want to make sure that the customer is not watching the fuel level gauge while he's accelerating.
Right.
So the biggest issue with aftermarket fuel systems, especially when a customer starts to modify the fuel pump module inside the OEM fuel tank, the factory fuel tank, is will I have enough fuel? Will they have enough fuel under load, under acceleration when the fuel tank levels are below half fuel tank capacity? That's where people start to get into a lot of trouble. Right. So with our fuel systems, especially the drop-in stuff that we make, we design it in a way, we engineer it in a way that they can drive it hard under load with the fuel level as low as possible. So we can get our fuel system, and I'm going to go on record for this because we have obviously the data, we have the records, we have the track data. We can get most of our drop-in fuel systems that replace the OEM fuel pump module. So it's not an external surge tank, it's a surge tank within the fuel tank.
Okay.
We can get it down to 5% fuel tank capacity.
So you can run with 5% of gas.
Yes, we can. And that's not at 500 horsepower, wide open throttle. That's 1400 horsepower, that's 1200 horsepower, because there's a lot of engineering that we've put into that tank to make sure that the in-tank module is always full.
Right.
Obviously. Now, look, when you have an external surge tank, of course, you can drive a car hard under load and you've got that reservoir. And there's obviously, you need to make sure that that's getting enough fuel under load and enough fuel is returning and whatnot. But that's relatively easy. The trick and the hard stuff is actually getting a replacement into the OEM fuel tank that performs like an external surge tank.
Right.
So when we think of surge tanks, we think of an external surge tank. But obviously the engineering and obviously the market's maturing so much that a lot of companies are making drop-in modules that replace the OEM fuel tank. But the problem is, does that aftermarket fuel pump module allow you to drive your car exactly the way it drives when you've got your factory fuel pump module in there?
Right.
And that has limitations as well. Obviously, when you start upgrading fuel pumps and whatnot, you'll get to a point where you're having an impact on the Venturi system. You may be creating a bottleneck there because you've got additional flow because of your aftermarket fuel pump, and that's getting a little bit technical. But that's the trick, is getting enough supply, not just when the fuel tank level is high, is when the fuel tank level is low.
But it's not ideal to run at 5%. Is it just a just in case, or like you said, under all conditions?
Look, it's
like, what do you get?
I'm not promoting street racing here, but look, if you want to accelerate and you don't want to sort of have someone drive up next to you and say, "Oh, hold on, I need to go into a service station. I need to fill up gas. Just give me a second." It doesn't work like that.
Right.
And the same thing at the truck as well. It's now you're talking about extra weight. So if you've got, I don't know the gallons, but if you're talking about a 70-liter fuel tank, I don't know what that converts to in gallons.
I don't know, but
15
I know
gallons,
my car's
maybe?
like 13 gallons.
Something like that.
I don't know if that's it.
That additional weight, and if you're trying to break a record and you're trying to go after a PB, you're running your tank at full fuel tank capacity. That's a lot of extra weight.
Right.
It's either you sacrifice that or you stop eating, McDonald's. right? So the weight has to come from somewhere.
Right.
So you shouldn't, and if you want to go out pass after pass after pass after pass, you shouldn't have to watch that, especially with the roll racing formats.
Yeah.
You really don't have that opportunity to go back and, fill up the tank. You may, but that's just a burden on the driver. The OEM fuel system doesn't work like that. OEM fuel system allows you to drive it hard all the way down.
Right.
Right. So why are you spending $50,000, $60,000, and then all of a sudden you're going backwards with the fuel system?
Right.
Yeah.
So why do you think that fueling isn't as important in America as it is in Australia?
I'm not going to say it's not as important.
Well, when it comes to building a car.
Yeah, sure. So obviously, I personally, I feel it's the biggest issue with most. And look, we obviously work with a lot of American customers and builds right now, whether it's Chevy SSs or ZL1s. Pontiac G8s. It's sort of our bread and butter at the moment. Obviously, like I said, we're going into different formats, but the principal complaint that we get is I can't drive this hard down a track or on the street under full fuel tank capacity. And Australia gives us a big advantage. We, and I was saying this to the guys at Ripper Tuned before, and I told you this as well. In Sydney, within a 25-kilometre radius, there's about 50 workshops. And it's not just 50 no-name workshops. It's all the guys that the Americans hear about, Everyone is close to everyone. Wow. So you have this crucible of, everyone working together. So if there's anything that I need, if I need to create a master, and I create all the master wiring harnesses myself. I'm still lead engineer, so I'm not just a guy that behind a computer telling people what to do.
Yeah.
I'm still lead engineer. Now, look, I've got a lot of smart guys in my team, so I'll create the base concept and I'll pass it off.
Right.
Shout out to Alex and my team. But we have access to, the world's greatest workshops, and obviously America has that as well. The US has that as well. But I was able to develop the fuel systems, in a way where I can validate that data immediately. I can validate outcomes immediately. Right. I've sat on the dynos. I've got countless hours on the dynos where I'm watching what's happening. Countless hours at the track. I'll run to the track and provide fuel, trackside support.
Yeah.
I did that last week. I did that the week before. And obviously, if you follow us on Instagram, on Aftermarket Industries, you'll see that I'm actually running to the track.
Right.
So I think developing a product, and the same thing goes for like TurboSmart and Haltech and all the Plasma and all these big Australian brands that the Americans would know of. We're so close to so many workshops that we can validate at so many different data points or so many different levels that it just matures a product very quickly.
Right.
And I don't want to have to say this, but Australia is no nonsense. You can't play with people's cars, and America's like that as well. But it feels like a little bit more intense in Sydney and Australia.
You were mentioning that there was some stuff going down over there.
Yeah, it's an intense market. But obviously, speaking to the guys here, they said that the US market is quite intense as well. But you can't. We've just the market's just developed in a way that you can't have a fuel system not perform. If it doesn't, you'll hear about it.
Right.
You know what I mean? So I think the status. I guess the benchmark is a little bit different. Whereas when I speak to some American customers that are hearing or reaching out to us for the first time, it's a passing comment. It's almost like, oh yeah, I just can't take my car down under half a tank. There's people watching this right now. There's a lot of people watching this right now that their tuners have told them that you can't drive it hard under half a tank.
On what platforms though? You've experienced?
Sure. Anything. So generally the Mopar stuff, the GM stuff, the Dodge stuff.
Trackhawks?
Yeah. Well, Trackhawk's have an amazing fuel system for factory, so no. Okay. Because they haven't. Yeah, the engineering has a dual fuel pump system. The Venturi systems are very well designed.
Yeah.
It's quite sophisticated because it has increased flow with the dual fuel pumps over sort of a standard application.
Okay.
But the GM stuff, I'd say, where there are a lot of products in the market where there is a replacement fuel pump module.
Right.
But the problem is, like I said, you start to, spend all this money on the engine, you got this power, and then all of a sudden, I think I was saying this to you the other day, it's like a bodybuilder, having a huge upper body, but he skips leg day, right?
Which is pretty common.
Well, right. Or it's like going to the UFC and say, I've got amazing wrestling, but I've got no Muay Thai. I've got no striking. You're not going to get far. So That, you know, and we keep a lot of this stuff, the Americans will say, on the down low. You know what I mean? It's seeing other products fail in the market gives us a lot more work, and we don't have to say anything about that. We don't have to throw shade at other competitors, because that gives us, yes, we may lose that initial sale because we're not the most, you know, affordable product.
Yeah.
We're not, our price point isn't here. Our price point is here. And I want to touch on that in a minute as well. We've developed in a very interesting environment in Australia that the products become very mature very fast, and not because you want it to, it's because the market makes you mature very quickly. Like I said, it's a no-nonsense approach in Australia. I'm sure you guys get all the racing videos and the drag racing videos. Yeah. It's crazy, man. It really is.
It seems like it's really competitive. And sometimes on Motive Video, they do a great job of recording a lot of the stuff out there. A lot of the stuff, you can't tell if it's like actual like drama or if it's like just friendly kind of competition.
I would say a lot of it is even watered down.
Watered down?
Yeah, there's a lot of stuff that happens behind the scenes. Yeah, it's pretty crazy. It's pretty intense.
I wouldn't even think that, because Australia, I mean, you wouldn't think that it's anything close to like what New York is, because New York is pretty intense.
Yeah, I think what you guys have, again, speaking, I don't want to sort of keep repeating it, but speaking to the guys here, you guys have, you have the forums. Yeah. So everyone goes on the forums. We don't really have that in Australia. We don't really, I'm sure there are forums. I'm sort of out of touch with that a little bit, but if someone wants to say something to you, they will turn up. They will turn up at your office. They'll turn up at your workshop, and you hear those stories. And it's not an occasional story. It's a weekly occurrence. And no one is susceptible from that. No one is immune from that. You know what I mean? You know, big brands will have people turn up at their facilities. Like, I'm talking corporate headquarters. You know, proper suit and tie organizations will have someone on the street turning up and throwing the product through the front door. Yeah.
What?
Yeah.
Damn.
Yeah, it's intense.
Australia gets down, huh?
It's intense, man. So you're forced to make sure that when the product is in the market, that they're not the guinea pigs. Now, sure, we've made mistakes. I'm sure all the big brands have made mistakes, and a lot of it comes down to, and it is our fault. You know, you hear the phrase or the quote, you know, customer's always right.
Right.
They are always right. You know, you may have not been clear on instructions. Your instruction guide isn't clear enough. You know, it's not detailed enough for whatever reason. And a lot of it comes down to trust as well. You know, I think the biggest, I don't want to rub anyone the wrong way, but I think the biggest failure for any business is to assume that common sense exists. I think there isn't any common sense in thinking that there is common sense. So you have to always make things and release things into the market to make sure that it's like you know, what are those dummies guides? You just got to make sure the things that can be installed by the average person. You know, not everyone is going to take their car to a workshop. They're going to try to do things that are right, and good on them. Let them try to do as many things as possible. And so no one is immune from that. Right. Especially us. You know, we have detailed 14-page and 28-page wiring guides, and people still get it wrong. You know what I mean? So you've only got yourself to blame for that. Right. I agree.
So can we kind of put together like a fuel system, like how you would design a fuel system for a car? What's the process for that? What tools do you need for that?
Okay.
And talk us through that.
So there's two parts to that.
Okay.
So if I'm designing a fuel system, so let's take a step back. What makes Aftermarket Industries unique is anything above 800 horsepower, I jump on the phone.
Okay.
Every single customer above 800 horsepower that we've ever posted, and we've got 3,400 posts or thereabouts, I will consult individually with every single project.
Why 800 horsepower though?
Or anything above, because we spoke about this before as well. It starts to get very complex above that number.
Okay.
You know, when you can push to 600 horsepower, 650 on unleaded. When you start to get above that mark and you need 2 fuel pumps, it starts to get very complicated, especially if they want you to work with their OEM fuel tank and the OEM fuel pump module. And I said this to you before as well. It's more difficult to design an 850 horsepower fuel system than it is to design a 2,500 to 3,000 horsepower fuel system.
How?
Okay. So if I'm designing a 2,500 horsepower fuel system, I know it's going to be on methanol. I know they're going to run stupid amount of boost, 80 PSI, 100 PSI. You throw a mechanical pump at it, you've got methanol.
Right.
You put, a tank at the front of the car, you run your fuel lines, you make sure that you sort of calculate your consumption and whatnot for staging, for the run, for the burnout, and that's it. Because the mechanical fuel pump is going to give you unlimited fuel. Now, you can't run that. Now, there are this is controversial as well, and I know people are going to hate me for this, but running a mechanical fuel pump on the street is not the way to go. And the reason for that is it's attached to the engine, and even if you're running a belt-driven pump, a mechanical fuel pump, you're transferring all of that heat into the fuel. And if you're not running methanol on the street, you're running E85 or ethanol, and a lot of customers will experience vapor lock because that's not designed. Running a geared pump is going to create a lot of cavitation as well.
Okay.
So it's going to create a lot of heat, and putting a fuel tank at the front of the car, and it's one of these points of frustration with us. You can't have a fuel tank in the engine bay. It's illegal. It's a fire hazard.
Isn't that dangerous?
It's super dangerous.
People do that.
A lot of people do that. A lot of workshops advocate for that as well.
I've never. Where does that sit though?
It would sit where your airbox sits, maybe, or a little bit lower.
Fuel
tank in front of your car. Now that's okay on a drag car, right? Because you have the roll cage, you have all the safety sort of protocols built around it. But running, and sure, you can run a belt-driven mechanical pump and with a tank at the back. But a lot of these guys run fuel tanks at the front of the car. Now that's illegal and it's a fire hazard. You can just think about what happens when you hit when you've got impact, right? So yes, 850 horsepower or 1,000 or 1,200 horsepower fuel system is a lot more complex, a lot more difficult, because now if I'm designing something for 1,200 horsepower and let's say the customer wants to work with his OEM fuel tank and an OEM fuel pump module, I've got to think about pressurization from my overflow back into the fuel pump module. I have to think about how I'm going to get power to the fuel pump inside of the OEM fuel pump module using the standard connector. Now, a lot of people will unpin these connectors.
Yeah, I've done that.
Yeah.
I've done that before.
So I'm going to put up a video in about a week. And
okay.
We did a test on, and look, the person had all the greatest intention in the world, doing a good job in terms of unpinning things and using mil-spec wire, but you're restricted in terms of the capacity of those pins in those small connectors. And if you're talking about a Supra, like an MK4 Supra, we'll put that video out. We measured the thermal, the heat of that connector, of the OEM connector, at 8 psi. So usually when an OEM fuel pump, it had an upgraded fuel pump, Walbro 460,
right,
pumping that fuel into a surge tank, that line is not regulated. You only have resistance against the fuel in the surge tank, which is very minimal because you have an overflow. And if that's sized correctly, there's minimal resistance. That line only had about 6 or 8 psi. The connector got to 98 degrees centigrade.
In the tank?
Yep.
So at what point would it be too much heat for it to cause a problem?
At some point that's going to impact the mechanical strength and the properties of the wire. The pump's going to fail because it has so much resistance and so much heat over time.
Right.
So it's one of those things where you see a lot of these, and you'll see in the late model cars as well. You'll see someone throw a booster pump, which is just a voltage booster, and it'll boost the voltage from 14.5 to 16 volts on a factory pump or a Walbro 460. Now, a Walbro 460 is not designed to run, at 16 volts for extended periods of time. And when you start throwing boost at this thing, you've got 58 psi base fuel pressure, and you dial in 15 pound of boost through a supercharger or a turbocharger. Now you're in the 70s. Now you're at 14.5 volts, you're in the 70s, and your current draw is going to be 21, 22 amps. The connectors aren't designed for that. The OEM connector isn't designed to run that kind of amperage. So what happens is people start blaming the fuel pumps. And workshops allow this to happen. I know I've run, and it's very anecdotal. Yeah, I've run that for 6 months, at 1 year. We've done that on all of our projects.
Right.
But we hear about every time it fails, obviously we're not the only fuel system company on the planet. Right. We're the only company that sells fuel pumps. But when someone turns around and says, my Walbro fuel pump failed after 50,000 kilometers or 30,000 kilometers or 6 months, Walbro is made by TI Automotive. That's That's an OEM manufacturer. That's a $3.5 billion per annum company.
Yeah.
That's what their sales numbers are. You know, all of these cars use Walbro fuel pumps.
Right.
All the GMs factory, like you hear about the Hellcat pump, that's a Walbro 525. That's made by TI Automotive for Hellcat.
Okay.
So the Chevy stuff, the ZL1 pump, that's a Walbro 460, right?
Right.
That's an OEM pump. When's the last time you had someone running a ZL1 Camaro, you know, untouched, you know, not running, you know, more boost than, you know, than factory, and that pump failing after 50,000 kilometers? It doesn't happen because it's an OEM grade engineered pump. So that's sort of like the push and pull of the situation, right? So to go back to your original question, if I was to design a fuel system, so there's two sides to this. Developing a new fuel pump, a new fuel system is different. That's part of your question, right?
Yeah. Well, if you wanted to, let's say if you wanted to make 1,000 on a Supra.
Sure.
Right.
So let's do this. So when someone calls Aftermarket Industries or fills in the fuel system calculator, we have a fuel system calculator. Now that's a dumb calculator that requires input from our end. So it's not going to spit out the answer. Obviously, there's a lot of nuances. You know,
can you do that?
Yeah, we do all that. So what happens is, so you fill out the fuel system calculator form. So anyone can go to aftermarketindustries.com.au and there's a fuel system calculator form. Put in all your details. If you put a fake number, a fake email, we won't contact you, right? So don't try to do that. And generally people are really good with that. So you want to run 1,000. So the question is going to be, what fuel are you going to run?
Okay, so let's say 85, which is
the 85, sure.
Right.
How much boost?
You Mark 4 or Mark 5?
Let's go simple with the Mark 4.
Well, how would you even?
That's like 35 pound, right? So most people will have that
at
number.
1,000, you would have to know.
Sure.
Okay,
so it could be like 35, 40 pound to get to 1,000, depending on the size of the.
But where are you basing those numbers off of? Is that just from experience and
that's from my experience. Generally, customers will have that number because the workshop will give them that number.
Okay.
So you've come to me, you said, okay, I'm going to run about 35 pound of boost and I want 1,000 horsepower at the wheels. That's the engine. You're running, 2JZ. I obviously know where your base fuel pressure needs to be.
Now, how do you know that? Because you calculated that for my build, but
sure, because I'm going to tell you where your base fuel pressure needs to be. We dictate where your base fuel pressure is and your fuel pressure ranges, because fuel pump and injectors work on fuel pressure ranges and voltages.
Okay.
Right. So an injector will operate at a higher flow rate, the more pressure you squeeze into it. Fuel pumps work in reverse. So the more fuel pressure you add, so that's your base fuel pressure with your boost, the more pressure you have here, the lower the output, because now you have resistance with the fuel pressure regulator.
Okay.
And then the more pressure you add, so base fuel pressure plus your boost, the more amperage draw, because the pump now is trying to support its output against the pressure. So 1,000 horsepower. So the first thing I'm going to do, and people can anyone can make note of this, there are formulas that we use that it's called the brake specific fuel consumption ratio. So how many liters of fuel I need or we need per horsepower. So, and that will vary on the engine, whether it's naturally aspirated or whether it's charged or whether it's unleaded. It just varies. And and the combustion cycle, whether it's a rotary, the stroke of the engine matters as well. So it's whether it's a 720 degree combustion cycle, whether it's 1,000 plus combustion cycle, that'll all vary. So I know at 1,000 horsepower on E85, you need about 710 liters per hour. And at 710 liters per hour at your 40 PSI base fuel pressure plus that's a 40 pound of boost. So 80 PSI, I need 710 liters per hour. So the first thing I do is I look at my charts and my graphs for the fuel pumps. What fuel pumps? Obviously, I'm going to need more than one one. Okay. And so I look at 80 PSI, and I look at your voltage range as well. So a question I'm going to ask you is how big your alternator is. So if you're in the 140, 150, 60 range, I know you're going to get about 14.5 volts. I know automatically I'm going to have higher output than what the data shows on the fuel pump flow charts that you get from the manufacturer. So I know generally the rule of thumb is for every volt that you add, it's about 10 to 15% increase in output for the pump. It's also about a 10% to 15% increase in amperage for the fuel pump as well, which you need to be mindful of, because that's your constraint. You can't push these things to 30 amps, right? To 20. You don't want to be at a point where the wiring in the pump, is going to be the biggest bottleneck, right? So you want to sort of keep in the 20 to 25 amp range, which is a lot if you've got a lot of pumps. So I know you need 710 liters per hour. And so I look at my chart and I think, okay, great. I can use 2 Walbro 460s, but I've got Walbro 535s available to me as well. They don't have check valves, so I can extend the prime time. I can run them full time. So I get 2 pumps, put in a surge tank. Now that's the easy part. Okay, I've got a surge tank.
Yeah.
Now I need fuel into the surge tank.
Right.
And my biggest bottleneck and constraint is going to be the OEM fuel pump module. So now we have products. It's called a bulkhead adapter. It's a billet part that has studs and it's insulated. And so that gives us, and you need to drill a hole. And the Supra has a very, very small diameter hanger.
Right.
So you don't have a lot of real estate there. So I need to drill a hole to make sure that the Walbro 460 that I put in there, I can get full current to that. There's no bottlenecking, so there's no 98 degree sort of issues with that. And those studs that we have are 80 amp studs, and then I run my own sort of mil spec wiring to that as well. And mil spec wiring is critical. We only use mil spec wiring and everything. And we have our own relays as well. We have a new PR40 relay, which is the world's first integrated PCB 2-way LED fault detection 40 amp relay with industrial grade copper. Okay. So it's important because we've developed this with an OEM manufacturer. So I have a surge tank. Now I have to address fuel coming into that surge tank. I need that surge tank full. Right. And then I need to now make way or space for the overflow from my surge tank into the factory fuel pump module. Now you're starting to get quite restricted in space because I need to make sure that the surge tank doesn't pressurize. And the return on Supra is a 5/16. It's very, very small. Okay. So I need to make sure I get a -8 overflow to this. If I want to run a low base fuel pressure, I need to make sure that there's no bottlenecking from the regulator back into the fuel system because everything works together. So there's no bottleneck in terms of current flow to in-tank pumps, to the pumps in the surge tank. So we use mil-spec wiring, and even the eyelets amp rated. So we make sure we use solid copper. Like we buy them from Taiwan. We buy, I'm happy to say, where we buy our things from. Our eyelets are from Taiwan. We get a catalog and it actually tells us exactly how much amps the eyelet can support. The pins, how much pins can support that connect the wire to the relay. Right. These are really critical things because you'll hear people talk. Often you hear it's that my fuel is heating up. I've got 3 pumps running. Look, fuel isn't just a propellant. It's also a lubricant, but it's also a coolant. There are properties in there that are engineered into the fuel with additives, right? So heating is a non-issue in a well-designed fuel system because a lot of the time it's probably your overflow, probably got wiring issues. But these are sort of some of the design challenges, making sure that the fuel returning from the engine, from the fuel pressure regulator, doesn't have a bottleneck because then you won't be able to drop the base fuel pressure down. So a lot of tuners will just, I don't want to call it lazy, but someone will take, that's a GM, a supercharged GM, or they're in a supercharged GM, and the base fuel pressure is set at 58, and then they'll just run boost on top of that. They should be dropping base fuel pressure down at 40, and then running your boost. Because once you lower total fuel pressure, you increase the output of the pump and you reduce the current draw as well on the entire fuel system. So these are sort of little considerations that a lot of people don't think about. And I don't think customers, and I don't expect them to because this is our bread and butter. We live and breathe this stuff. We've been doing this for 24 years now. Right. So they're huge considerations. Now, on the flip side, 2 months from now, we'll have a Supra kit. So if you were to contact us 2 months from now, then we'll have a drop-in module. Mark IV, that has an aftermarket Venturi system, that's a billet Venturi pump that's capable of siphoning about 3.6 to 3.8 litres per minute, which is the equivalent of a Walbro 255 with no current draw, an active valve system, which is, we were the first to have an aftermarket fuel system that had an active valve system. Our buckets surge tanks, for our drop-in modules, injection molded using a composite material mix. I won't give you details on that because that's super difficult to get that right. But our valve system, what it does is it works with the weight of the fuel. So when you accelerate, the valves close, and the Venturi system is siphoning, and you've also got the fuel coming back from the engine. So it creates a surge tank within the OEM fuel tank. Now, for a lot of people, that's hard to grasp that concept. How can they guarantee 5% fuel tank capacity, able to deliver, fuel under load and until right down to 5% fuel tank capacity We can do it because it's engineered. Because this is sort of part of your question as well. When we start developing a fuel system, we'll buy the fuel tank, we'll scan the fuel tank, we'll start designing the fuel pump module, then we start running CFD analysis. And we hire some really smart people, third-party companies to validate our data. So they'll create all your data points, and your data points are under load, what does the fuel look like? Because inside of a fuel tank, when you accelerate, that fuel pushes to the back.
Right.
Now, the more torque you have, the more G-forces you have, the more severe that fuel, that wave looks like, just to sort of keep it simple. So you've got to make sure that whatever you're designing and you're making guarantees like we do, if it drops into the OEM fuel pump module, or to the tank, how do we trap fuel? How do we make the Venturi system, operate as if, it were an in-tank fuel pump supplying an external surge tank? So there's a lot of these little nuances that you have to consider, and then you can make these guarantees. So so back to that point, buy a fuel tank, you scan the fuel tank, you start designing, using CAD,
right?
What it looks like, and then you start basically validating that through CFD analysis. And then you get to a point and you're like, we're happy with this. We don't need a guinea pig, but then we'll go out to a workshop, we'll run it on a dyno, we'll go to a track, and then we can say, great, this works great. Now, version 1 may not be perfect. And I don't mean perfect from an engineering perspective. It may not be perfect from a fitment perspective, because the ergonomics, and it's interesting, a lot of the times we'll make changes to a product will be based on fitment, because I can go out and watch how a workshop fits something. I'm like, that's interesting. They ran the fuel line like this, or they ran the fuel line like that.
Yeah.
So now I go out to workshops and I obviously fit the first, I create the master, hoses and the wiring harnesses. So we don't leave that to chance anymore. But so that's basically how it works. And for us, can take 200 to 400 hours to design a fuel system. 200 to 400 hours. Yeah.
Wow.
And not just one person, 3-4 people, and then maybe 200, 300 hours of CFD analysis as well. So that's just running simulations, with all the different data points. What if this scenario? What if that scenario? What does it look like under braking? What does it look like under cornering? Because we work with time attack. A lot of our success comes from time attack. Actual track cars, and it's not just cars coming 5th, 6th, and 7th. It's, first place, second place. Like we've had years where the first 6 customers, the first 6 finishes, 1st, 2nd, 3rd, 4th, 5th, 6th place are all Aftermarket Industries projects. And it's not off the shelf products. We don't deal with online retailers. And I've been very strict with this, with the business, and I could have made a lot more money. I could be living in New York and, living on Park Avenue. And I'm being funny, but we only work with workshops. We want people that can install the product, that can tune, and that can give us feedback, or can assist the customer in terms of troubleshooting. Right. So this is a big part of the business as well.
So is having 2 fuel pumps better than having 1? If I ever wanted to add a 450 into my setup, I could have. But does that really make a difference?
Yeah, good question. That's an interesting one. So the answer is, it depends on the situation. Okay. So sure, I can have 1 fuel. Let's say, for instance, I have a 600 horsepower project, and it's a Chevy SS. They're running 10-pounder boost. I'll get them to drop the base fuel pressure down. Now, dropping base fuel pressure means I've got to go bigger injectors. So that's a consideration as well. Right? Because the injector's now gone backwards, right? So I'm not squeezing more fuel pressure through them. So I'll give you a scenario. Let's say you come to me with a supercharged Chevy SS. I get you to drop the base fuel pressure down to 40.
How do you do that though?
Fuel system control module.
Okay.
Yeah, so they can adjust the ranges. So there's products out there like HP Tuners software. They can download these edits, and then they can modify. Look, a Supra, you can just drop it down with the fuel pressure regulator. Okay. And obviously you need a fuel pressure regulator to be able to drop that down too. But the fuel system control module with these later model cars, they're quite tricky, and you need to actually go in there and adjust the KPA or the pressure ranges. Okay. Scale the injectors correctly, or not, kill certain modes, because it'll it'll tell the ECU, hold on, like this isn't running the way it should
on
be.
newer cars, right?
On newer cars,
So
yeah.
on an older car, you can use the fuel pressure regulator.
Yeah. It's a lot. Obviously, the newer cars have fuel pressure regulators as
Right.
well, and that's the first point of setting things. But the fuel system control module will throw up a lot of errors, right?
Gotcha.
So it'll say, hey, I'm not reading things correctly. This isn't the way things are working. And you'll get a reading where, oh, I'm reading lean, but I shouldn't be. I've got
Right.
2 fuel pumps. So the answer is this. So I'll give you a scenario. So if I've got a Chevy SS, it's supercharged, and they want 600 horsepower at the wheels, and it's going to stand unleaded, so not E85. I can get there on a single pump. So with 40 PSI base fuel pressure, 10 pound of boost, so 50 PSI total fuel pressure, with the voltage, big alternator, I can get there on a single Walbro 460. I'd be squeezing it, really squeezing it. But the problem is this: the supply to the engine or the injectors should never be a 1-to-1 ratio. Okay? I'll tell you why. You want fuel coming back, because what's keeping the bucket full? It only has a valve and a Venturi system. And the Venturi system, it's a siphoning system. So it creates a vacuum. So the fuel, unused fuel, and obviously that's all happening inside the factory fuel pump module with an OEM system. But that Venturi system needs to create vacuum. So it needs fuel returning through it. Okay? So the more fuel I've got coming through the valves and returning back, and from the Venturi system creating a vacuum, the fuller it is. Right now, you can't put a dual fuel system on an OEM fuel pump module with a Chevy SS. So if that were a scenario and a customer came to me, I'd want to push them to a dual fuel pump module. Now, if it's a race car, if it's a street car, I can put some caveats in there. I could say to them, look, you can run that like that, but you're not going to have much fuel coming back. So you need to watch things, right? Okay. That's a scenario where you need to say this. And we don't really work in that range as well. I'll just be honest with you. But we do have race cars that run 500 horsepower that will go out through track, like, Australian. We have the Holden VE and the VF, which is the Pontiac G8 and the Chevy SS. Right. Now we do, with Pinnacle Road and Race, which is a workshop, they run in the lower classes of V8 supercar series in Australia. They only run about 500-600 horsepower, or about 500 horsepower. We'll run 2 fuel pumps. The reason why we do that is because with our Venturi system, the more fuel we have returning through the Venturi system, the higher the siphon rate. So that creates a vacuum from the other side of the fuel tank, and that keeps the bucket full. Okay. So you need to think about that. And even with an external fuel system as well, if you're using everything you're supplying and nothing is going back to the surge tank, sure, maybe I've got 2 liters in there displaced, or 1.5 liters displaced, and maybe that's going to get me through a quarter-mile run. But if you're doing 1-mile racing or circuit racing, no. If you're under load, we can calculate the actual rate of depletion and a replenishment rate of a surge tank. You just basically look at what your consumption ratio is, what you're consuming, what's coming back, what's flowing into the surge tank, and you can work on numbers and what your quarter mile is. So it's technical. It's really, really technical.
Now, what if you want to run E85? There's a lot of misconceptions about E85 and what is needed to run it, and also the consumption as well with it. So can you talk about that if you wanted to run E85 on your setup?
Sure. So can I respond to sort of what I've seen online without throwing shade? Okay. Look, I've seen... The thing about fuel and motorsport is everything's an echo chamber. It's like a John Wick thing, right? I try to sort of joke with this. You can't mess with someone's car, and you can't mess with someone's dog. You know what I mean? People do go John Wick, especially in Australia, and I think in America as well, especially in New York, man. In New Jersey. So, yes, if you're on E85, unless from factory, and we're talking about forced induction, let's keep it real. Yes, it increases your consumption. Right. Okay. Now it's not as severe as most people think. Now, if I'm going from naturally aspirated and I go to forced induction and I go to E85, sure, it's going to be about 30%, increase. Right. Now, if I'm already at forced induction, so supercharged or turbocharged, and I'm unleaded and I go to E85, it can be as high as 20%. Now, if I go to if I have a extended combustion cycle like a rotary, sure, that can be as high as 30-40%. It's almost with a rotary on E85, it's almost a 1-to-1 ratio. So if I need 1 liter per horsepower. So if I have 800 horsepower, I need 800 liters per hour. Wow. Yeah. So with something like a Supra, I can calculate that at 0.71 liters per horsepower. Okay. Now, if it were just unleaded, it's generally 0.63. So you're jumping up from 0.63 to 0.71.
Right.
Okay. So obviously the fuel's a lot denser. I have heard, I watched a video online. Again, I don't want to throw shade at the gentleman, but it's incorrect what they said. Do you need to upgrade injectors and fuel pump? Yes, unless somehow your OEM injectors and your OEM fuel pump has compensated for that additional flow.
Right.
Now, sure, you can do things like dial your base fuel pressure down. You can get a lot more, out of your pump, but probably not your injectors. Okay. So one or the other has to be upgraded. There are little tricks. So yeah, if you're talking about a reasonable horsepower, maybe like 400 horsepower, you're going from like 300 to 400. Sure, maybe your injectors are going to be okay, but we're not dealing in those project ranges. We're dealing with 400 to 1500 horsepower. Yes. And the bread and butter for Aftermarket Industries is really, like I said, above 800. But we play with 1200 to 16 to 1700 horsepower now. Right. The amount of projects that 1500 is the new 1000 now. It really is. And now we've got customers going to 1800, 1900 the wheels on street cars, which is, I think one of these is going to 1800 that we're going to be working on with the Ripper Tune guys. I don't think this one, it's pretty, and I think they're building one for 2500 horsepower as well. So the other consideration as well is if you go to E85, it's going to start to eat into the materials. So
over time.
Yeah. Right. Look, and it could happen quite rapidly as well. So if you've got your O-rings, your injectors, unless they're stainless steel, it's going to eat through the injector as well. You know what I mean? If
you let it sit, or just even if you're running it?
Look, it's hydroscopic. So if your car's sitting like this in a garage, it's going to draw, moisture from the atmosphere. So it's always breaking something down. It's an organic, right? So it's breaking things down around. It's highly, highly corrosive. So unless you've got Viton seals, for your O-rings, and most factory vehicles will come out with MBR, and that reacts to ethanol. Right, it expands, it starts to break down. So yes, E85 burns a lot more, gives you more power. Obviously, addresses things like detonation. Your consumption ratios go up. Right. And yes, you need to start to look at what part of my car is not compatible. And a lot of fuel hoses, like old school fuel hoses, like if MK4 Supra, that fuel hose is not going to last with the 85. Right. It's going to tear through that entire thing. Right. It's going to expand, and that's what's going to happen. So it may not fall apart overnight, but it's going to react to its exposure to the ethanol.
So what kind of fuel line should you be running if you're running this ethanol in older cars?
Okay, sure. So you'll see the hard line will always be compatible. So if it's an aluminium hard line, because the radius is so tightly packed, it'll always be compatible. Okay. But if you run, so aftermarket fuel lines always go for Teflon.
Teflon.
Yep. You can sort of get away with the braided stuff, but then you'll have that smell. So the Teflon layer stops the smell from permeating out. So you'll have obviously the microns. It'll still allow a certain amount of microns into the atmosphere. So yeah, look, you need to address your fuel lines, injectors, and if you don't look after your E85, there are E85 stabilizers now. So if you're running E85 and your car's going to sit for like a week, you should be pouring in, a can of E85 or a bottle of E85 stabilizer. I don't know what brands you have in America. Right. We have them in Australia.
Can you cycle out with like pump gas 93 every now and then? Is that safe to do?
If you're fuel flexing, you can, but you can't unless the tuner, the workshop is built in. Right. The different, fuels. No, you can't just put, unleaded into E85 tank. You need to have all of that addressed.
Right. Yeah. On a flex fuel setup, I mean.
Yeah, sure. Yep.
So you mentioned that you have to upgrade your injectors for E85, right?
Yes.
Is this mostly on older cars or newer cars?
From a like deterioration perspective, if you're running, that's a Bosch 2200s that don't have stainless steel internals, you have to keep an eye on it. You really do, But if you're running like Bosch Motorsport 1650cc, they have stainless steel internals. The ID 2600s they have, which are the Bosch, basically a Bosch Motorsport injector. They have stainless steel internals as well. So you don't have to keep an eye on the material within the actual, injector failing or corroding or whatnot. But you still can't let E85 sit because it'll build up. It builds up a gum. Right. And that stuff gets into your injectors and you're done. Right. So as a tip, as a rule, you should always have your injectors flowed and cleaned and tested, and it should be every 6 months.
Every 6 months.
I think every 6 months. I think every 3 months. If you're not driving every weekend, every week, then I think every 3 months or 6 months is that's maybe being a little bit too cautious. But I'd say every 6 months minimum.
So
and fuel filters as well. You know what I mean?
Fuel filters, right?
Yeah, E85 eats into that.
That makes sense too. Which you probably have to upgrade that for sure, right?
Yeah, like we have a stainless steel fuel filter for the Walbros that we developed that has an internal skeleton so it can't collapse. The Walbro fuel filters with the 85 are pretty good. Obviously, ours are better, and I'm just stating facts. They are, because they're stainless steel. It's a 200 micron. It creates no resistance, restrictions on the inlet. And they're stainless steel, so you can service them, you can pull it out, you can wash them, you can soak them in solution.
Right.
Yeah.
So when it comes to picking your injector size, what do you base that off of? Let's say if you want to run 1,000 horsepower, I feel like people just do what the shop tells them. But how do you guess yourself? How do you know yourself?
There are calculators for this.
Okay.
Yeah, there are calculators for this. So actually, I'll give them a shout out. I've never given them a shout out, and we don't really work with them. But everyone can go to a website. It's called witchhunter.com. Go to injector info, and then you can type. It'll ask you for your crank horsepower. So basically take your horsepower, multiply it by 1.25, and then it will ask you for how many injectors you want to run, and then it will ask you for basically your consumption ratios. And that's the trick. You have to know what your consumption ratio is. So we know all that data. I'm not going to give all that data out for free. You can fill in our fuel system calculator.
Right.
We'll always get back to you.
Right.
So if you put in the correct data, it just stops us from having to develop that calculator. Yeah. It'll spit out a number. It'll tell you that you need 2600 cc, and that's 2600 cc's at wide open throttle with your peak fuel pressure. So it's your base fuel pressure plus your boost, and that'll give you an accurate number. And then you can dial in your duty cycle as well. So you can say, I want to run things, I want to run my injectors at 80% duty cycle or 70% duty cycle, and it'll give you that number. And it's a very, very accurate calculator.
Now, I've always wondered about duty cycle. Can you talk about that and how that's measured? Why that's important?
Yeah, that's a good question for a tuner. So, it's a really good question for a tuner. It's basically how fat you want to run that tune. You know what I mean? The lower the duty cycle will depend, obviously, on how look, you can squeeze something to 90% duty cycle,
right? But
you're nearing the bandwidth of that injector.
Okay, so it's basically like running a pump at max.
Yeah.
Okay. You want to have it obviously lower and have more room up there.
Yeah, it depends where you are.
Depends on where you are.
Yeah.
Right.
So if you sort of don't want to go to a bigger injector and you want to sort of run at 90% duty cycle, then a 95% duty cycle, you're getting up there in terms of its limit in terms of its bandwidth.
Right. So is it possible to run too big of an injector?
It's a good question.
Because I've heard that people have said that if you run too big of an injector, you get like idling issues. Car runs a little funny when you idle.
Look, I think it depends on who's manufactured that injector.
Okay.
We don't see that issue. Look, there are a couple of decibel places there for tuning. So if the tuner wants to put in the effort, the workshop wants to put in the effort, I'm pretty sure you can tune a lot of the issues out. We haven't seen that issue, I'll be honest with you, because we only work with Bosch Motorsport injectors. Mm-hmm. But sure, look, a lot of people need to realize that a lot of the injectors on the market, and again, I'm not naming names or brands, are modified injectors. They're basically bought out. So Bosch will make the injector, and then a third party will bore them out.
Right.
And you don't have the same characteristics as from factory, So that could sort of skew the way that injector, performs,
right.
At lower outputs. So yes and no. Depends on the injector. No. But we run 40 psi base fuel, base pressure, and we go as high as 3300s.
3300.
Yeah. And we've not seen single issue. But the 3300s are fuel techs, you know what I mean? Again, we use Bosch Motorsport injectors. The injector dynamics obviously have the 2600, which are a great injector. We don't play with injectors because it's not something we make.
Right.
So it's not one of those things where I want to get into, he said, she said, anecdotal. We see the data. The Bosch Motorsport 1650cc injectors, everything. Look, if you're running an 8, they're perfect up to 1200 horsepower. If you're running like a 6, they're perfect up to about 1000 horsepower. Again, depending where your fuel pressure is.
Right.
And then you go bigger than that. And then a lot of people will run 2000s, 2200s, but I've not seen a 2000 or 2200 from a manufacturer that I personally want to stamp with our product that is not modified. So it's 1650cc Bosch Motorsport or the 2600 IDs or the 3300 Fuel Techs.
Right. So how do you...
And let's give a plug to those guys. You know? We don't make them, so why not?
Shout out to them.
They've never let us down.
So how do you plan to kind of make your way into the U.S. market with your product?
Okay, so I used to live in New York.
Okay.
Yeah, so I lived here for about 2 years, and we tried to build...
What part?
I actually lived in a few different places. I lived in, so it was Dumbo, Financial District.
Dumbo.
Yeah. Yeah, it's very expensive. So I didn't last long. Midtown East. Midtown East, and then the most of my time was in Brooklyn. So
Brooklyn.
Went to the Brooklyn Nets games, season opener 2022, 2023.
Yeah.
Lived in Williamsburg.
Yeah,
so it's for anyone that lives in Australia, it's like I call it the Bondi favelas. It's a little bit more grimy than Bondi, but it's sort of that hipster vibe. A lot of Australians.
Yep, it's definitely hipster for sure.
Yeah. And McCarran Park, and you've got a running track there, so it was great for that. And then you're sort of out of the chaos of Manhattan.
Yeah.
But I love New York. Obviously, I love Sydney as well. Look, this is a very difficult market to build a brand. Some Australian companies like Turbo Smart have done it well. It hasn't been easy because Americans are very patriotic. And we learn a lot about our own brand in terms of the way that we structured our business model now, and our go-to market strategy is based on my time in New York.
Okay.
Because Americans want everything easy.
Yeah.
They do, right? It's everything sort of. I think there's a few comedians that talk about the consumerism of it all, but I think Americans just want easy, out of the box, with someone that they trust, and they wanted it yesterday.
Right.
And being in Australia, I don't think a lot of, and look, I could be wrong, I don't think a lot of Americans buy directly from Australia. They want it in America, and they want it yesterday. And that's something that we've struggled with a little bit, being a smaller company. We don't have the market size like our American competitors do. So we spend all of our time engineering, manufacturing, just to keep up with supply.
Right.
With demand, sorry. So that was a bit of a challenge. So this is the second run now. We've got some good partners, especially Ripper Tuned, Real Street as well. So we're making, I don't want to say another run, but this is just obviously the next iteration. We're focused on the American cars now. Obviously, up until now, it's been the Australian vehicles, but our fuel systems support our drop-in plug-and-play fuel systems in Australia with the Chevy, the similar platforms to Chevy, are plug-and-play for the American model. So we have plug-and-play fuel systems for the Z01 Camaro, the SS Camaro, the Pontiac G8, the CTSV, the Chevy SS. I think I said Pontiac G8. Plug-and-play for the Jeep, up to 1,400 horsepower. And we have packages from 1,000, 1,200, and 1,400 at the wheels. On the 85 at the wheels, working as a surge tank with fitment inside the factory fuel pump.
Nice.
Factory fuel tank.
Yeah.
Mil spec harnesses, everything. No cutting, nothing required.
Right.
Hose kits and everything. So that's the focus, is bringing that plug and play option to the American market, because right now there aren't many, and I'm probably going to give the competitors sort of an idea of what we're doing. The Mustang kit's coming out as well. That's all plug and play.
So that's it's a good market to do.
Yeah, the Dodge platform, the Hellcat, the Charger, the Challenger. These will, within the next 4 to 5 months, these will all be plug and play. We've developed the modules already.
Right.
So when I say the module, the surge tank, drop-in surge tank, we've developed that already. The Supra, we can talk about your project. We're going to obviously develop that as well for the new Supra.
Yes. Which honestly, I think with the new Supra, they're breaking records with it already. It's pretty impressive how far they've gone in such a short amount of time.
Yep.
However, it seems like the Supra guys have it kind of figured out with the fueling, because I think it's the way the tank is designed. I'm not sure if you looked into it.
Yeah. So just to sort of give a little bit of referenceability to the American audience, we've been around for a while in the States. Like we were doing 800,000 horsepower Hondas back like 10 years ago, and in Super Street, they were aftermarket. Before the competitors came on board, we were like the first. So that grey Supra down in LA, California, Petrodactyl.
Yeah. Oh, yes. Oh, I can't forget about Mark. Yes.
Yeah,
Mark.
I designed the fuel system. So that's the
Right. That's right.
That's the grey Supra that was the first one to run 2Js
First
there with a
2J.
manual transmission.
Correct.
I designed the fuel system for that.
Right. I forgot about that.
Yeah.
Yes, we spoke about that.
Yeah, SEMA last year we did about 8 or 9 cars at SEMA
Yeah.
for Toyo Tires stand. Johnny Gromwald with his RX-7. I think we've done 6 or 7 projects with Johnny now.
Yeah.
So street car takeover in Texas. We won that last year as well.
Right.
With the Chevy SS with the big AI logo. So we do some important projects in the States. But getting back to the Supra, there's options in the market. And again, the trick is if you're going to develop an aftermarket fuel system,
Yeah.
for especially a late model car like a Supra, you want to do it in a way that it performs better than OEM, and no one's cracked that. And we know for a fact that no one's cracked that.
That's a fact.
No one's cracked that.
Yeah.
We've cracked it, and it'll be released with your project. And it's simply just taking what we've done with all these other projects and pulling it across and simulating it. Because at the end of the day, fuel sort of acts in the same way under acceleration. Like, our time attack projects are doing 2.2 Gs through the corners. So if we can design fuel systems for 2.2 Gs through the corners, then you'll never have a street car that runs 2.2 Gs through the corners.
Yeah.
So I think we have that advantage. The Supra is going to be the big one. I think as it hits the sort of aftermarket, as the maturity in the aftermarket sort of space starts to grow, I think you'll see a lot more conversion kits with the 2JZ.
Yeah, no, I think even if it's a 340, for example, like a BMW, pretty similar to the Supra, same motor, that hasn't been figured out yet. I heard a lot of people who are running higher horsepower numbers in the 340s are having issues with the fuel pump assembly itself.
Yeah.
So the pumps and all that stuff.
Yeah, look, there's a lot of work that goes into it. Look, and this is the thing as well. You're treading on the toes of OEM engineering and OEM resourcing. So if you're going to design something, and it sounds a little bit, and I don't want to come across as arrogant. It sounds, someone listening to this, I'll be like, how do these guys have better engineering than OEM? But when you study something and it's your life, and you have a team of 7 engineers, and all you do, and not just 7 engineers that you plucked out of university. Our guys have worked for Formula One teams, for Volkswagen Group, for Audi Group, for Fiat Group, for Land Rover. So we have a team of people that actually design these OEM fuel pump modules, and we don't have those constraints in terms of materials. In terms of weight. We develop. I feel like sometimes with these fuel systems, it's like it's the last thought. Just make sure that this thing can supply enough fuel on the load.
Put the pump in there, that's it.
Sure, you injection mold it, put the fuel level sender on it, put some valves, and we don't want this person to go crazy and put aftermarket, pumps in there. So just, design it for that, and for that, it's well engineered.
Right.
So, but if you're going to play with BMW engineering and German engineering, I've seen, just to talk about this for a second, I've seen aftermarket sort of hats, that use like you can't start playing around with those kind of things. You know what I mean? Because now, sure, you've got an external surge tank, but do I have enough fuel going and keeping the pre-pump in tank nice and safe and submerged in fuel? Because people don't realize that as well. When you start playing around with in-tank pumps to supply surge tanks, and sure, that operates well, with 300 horsepower and fuel, the way that fuel acts under that sort of load and torque. But now you've got 1,300 horsepower. Now the in-tank pump's not always going to be submerged in fuel because the fuel is going past it. Now, at what point is this going to fail? Because I said fuel isn't just a propellant, it's also a coolant. So at some point, if this has enough instances where it's not submerged in fuel, it has a motor.
Right.
It could burn out.
Could burn out, right?
Yeah. And I won't lie, with Mark's build, that ECU, I talked about the fuel system control module.
Yeah.
The factory ECU, wants to read certain endpoints, and it wants a certain amount of data. And when you start playing around with the fuel system and it's not behaving in the way that the OEM engineers intended, it's going to start throwing up a lot of errors. And it's not giving you, because now it doesn't have an actual, it doesn't have the state of play, I want to say, in terms of these, you can't see what it's supposed to see in terms of, well, that fuel's not going to the end point. Now it's going somewhere else. I'm not getting, it doesn't correlate. The fuel flow doesn't correlate with the in-tank pump as I can see at the injectors.
Right.
So I know Mark's project had some of those difficulties, and I worked with Sam. I think over at 316 Motorsport. But that was some of the sort of, teething issues, and they resolved it pretty quickly.
He's using a factory setup?
We have an external surge tank. We have an SPI,
okay.
Aftermarket Industries SPI 1200 V2, and then we have the OEM fuel pump module working with an aftermarket surge tank, and obviously that's delivering fuel to the injectors. And then we have everything going back through a surge tank and overflowing that. But we kept and retained the OEM fuel pump module as the main supply or the pre-pump into the surge tank to keep the surge tank full.
And then you had issues with the codes on the BMW.
Yeah, so they had some issues with the codes, and I spoke with them and gave them some ideas, and that got resolved pretty quickly. Yeah, but I can obviously see the issues that people would have with that. Yeah, because they're quite switched on over there.
Right, BMW can be, everything has to communicate.
Look, we're developing. Actually, I should say this as well. Developing a drop-in fuel system for the C63, the
Mercedes.
You know, for everything above 2012, and just trying to design a hose kit for this thing. Yeah. You know, I look at this and think the engineers are like, no, don't play with this. You know what I mean? No one's putting anything in this.
That's how I feel about BMW.
Yeah, really. The guy's like, no. We're engineering this. No one's touching this. You know, you've got to pull off 50 panels just to get access through fuel lines, and they squeeze the space so you can't. You know, the diameter is about this big, so you can't put anything else in there. But really, like, if they're going to warranty these vehicles, they don't want, you know, other than aero, you know, mods and lowering a suspension. Even suspension is debatable. Like, some of the suspension is so good from factory. I don't think these engineers want people to play with these fuel systems and modifying these engines, and it's apparent on the Supra as well. Right. You know.
Are we going to see you guys developing any kits for Hondas at all?
I'd love to do some kits for some Hondas. There's one here,
but
there is no but. It's just getting. So we have the quickest Honda all-wheel drive Honda in Australia. Yeah. Which we were at the track. They obliterated the Australian record. The Australian record was 8.9. It's in its infancy. It's only had 2 outings. Yeah. Mohammed is his name. It's a EK Civic. It's a grey one. We went out to the track together with my partner. Ran an 8.6. Okay. Absolutely smashed the Australian record, and he's on the hunt for 7s. So I'd love to have a drop-in fuel system for the old school EK Civics and the Honda Civics, but getting access to those cars is a little bit difficult. Getting access to a project in Australia that's above, 1,000 horsepower. Yeah. It's not, we don't really have that market. You know what I mean? Like, you've got the Hondas running 7.1s now. But yeah, if there's anyone building a quick Honda or a quick GTR or a quick anything, they can reach out to us and to me.
GTRs, you could definitely tap into that market.
A lot of the big GTRs, obviously in Australia, they're running 6s now, which is just crazy. They're running mechanical pumps, methanol, whatnot. But we do, we do a lot of GTRs, R34s, R32s, R33s, 13, 14, 1500 horsepower.
No R35s?
Yeah, a lot of R35s, but R35 is a little bit special, you know what I mean?
That's what I mean, yeah.
I feel like people have sort of pulled back with them. And you've got the 1 or 2 that have gone crazy, you know, running 7s. What's the quickest R34 in the world? I think it's like a 7.1 or 7.2. But 32s, we still do a lot of 32s. We're actually developing a fuel tank, a complete replacement fuel tank for the R32. Mm-hmm. It'll be actually a 12-chamber OEM fuel tank replacement. Yeah.
Wow.
Yep. Injection molded. So we started working on that, I think, last year. That won't come out for a couple of years. Mm-hmm. Look, people need to realize we're not 100 staff. We'll put some drawings out, and then it'll probably take 18 months to 2 years because we've got so many projects on. But yeah, R32 will have a complete replacement tank that will run. We're not decided whether we want 3 pumps or do 2 pump fuel pump system that can also run the new brushless pumps.
Okay.
So
which we didn't even talk about.
Brushless pumps are exciting. So I talked about sort of mechanical pumps. Mm-hmm. Now there's been, understandably, a lot of people have gone to mechanical fuel pumps, but now brushless fuel pumps, the output of the brushless fuel pumps.
What is the difference though? Just in a very basic term, mechanical fuel pump and...
mechanical fuel pumps, 2,000, 3,000 litres per hour, but you have brushless fuel pumps with third-party controllers. So TI Automotive made a fuel pump for the Chiron, for the Bugatti Chiron. It's called the BKS 1000. There's, I think, 2 versions of that now, and Injector Dynamics has gone out and built a third-party controller. It comes with its own controller, but that only pushes the pump to 500 litres per hour up to about 120-130 psi. Consistently can hold that flow. Injector Dynamics, and shout out to them. We don't work with them, but I shout out to a good product, and we don't work with them for no other reason that we're not in the States. They can push that pump to 1180 liters per hour from 0 to 140 psi, which is crazy. So that's
big power.
Yeah, look, when you start to get above like 100 psi, you start Walbro's, these turbine style pumps start to fall off.
Yeah.
You know what I mean? And that's why you need to go to a mechanical fuel pump.
Okay.
But I can tell you right now, a lot of the big cars in Australia that were running mechanical fuel pumps, like the B2R guys, the GTR guys that you see, they've all switched to brushless fuel pumps because the technology has caught up now. Right. So that's something we were developing our own, and we just weren't happy with the results. And they're expensive. Right now, they're expensive. I can see the price coming down, but it's no more expensive than going to a mechanical setup. But now, okay. So now, when you've got these Hondas that only have 4 cylinders and you can only run 2 injectors per cylinder, they need to run big base fuel pressure, right? So like an 80 psi base fuel pressure, because injectors just aren't enough.
Right.
You don't have enough injector, and then you start throwing in 60 pounder boost. You need pumps. Like, typically they would go to these mechanical fuel pumps, but we've got cars now, Mohammed's car, that is running one brushless fuel pump, but that brushless fuel pump is using a controller from another company, and that pump can output 1,600 liters per hour, 1,650 liters per hour consistently across the entire range, fuel pressure range, up to about 160 psi. Typically, 1,800 with like 50, 60 pounder boost, you would need, you would need 4 pumps. You know what I mean? To get that with that huge fuel pressure range, 3 pumps maybe. Yeah, look, you can get 1,850 up to about 100 psi with 3 fuel pumps. But now you've got 1 fuel pump. You can control the speed of that fuel pump as well. Yes, it's expensive, but it comes with a beautiful controller. But I guess what I want to go on record and say is you don't need to go to mechanical now. In a lot of instances, you don't need to go to a mechanical fuel pump. You can play safe, keep it legal, run a surge tank. All of our surge tanks now are all compatible with brushless fuel pumps. With the BKS 1000, you can run that. And our drop-in modules, because it's a taller pump, it's much taller than a Walbro 460 or 525 or 535.
Yeah.
Some of our modules will be able to accommodate that. So for the Trackhawk, you'll be able to run one of those brushless fuel pumps. That one brushless fuel pump in this, with this sort of capacity in engine and stroke, we should get probably about 1,750 at the wheels with one pump. Yeah.
When will that be available? Is it available now or?
In about 4 to 5 months.
4 to 5 months.
And that depends on fuel pressure ranges. Obviously, we're not talking 50, 60 psi of boost in something like this. We're talking like a 40 psi base fuel pressure with big injectors like 2650s, 2600, and then about 20, 25 pound, 30 pounder boost. Easily support about 1750 at the wheels. And that sounds unbelievable. One pump can do that.
That's crazy.
But that pump is like 25. The controller alone is about $2,500. So look, it's horses for courses, right? So if you're going to spend that kind of money, because the only other alternative is to run a lot of fuel pumps or go to mechanical.
Right.
So what I'm saying now is you don't need to go to mechanical in a lot of instances. You can just go to a brushless fuel pump. And you can pair, you can pair a brushless fuel pump with
the mechanical?
No, with the turbine style pump.
Okay.
So again, as long as it's sort of under 100 psi, that's the issue. You need to make sure that your injectors are big enough. You can run your total fuel pressure is low enough that you can get away with running, turbine style pumps.
And how many pumps can you fit in an OEM tank?
With surge protection. Now, this is the differentiator with our stuff as well. So we have street kits, which don't have a surge tank, which everyone else, most of the manufacturers make, where they'll just have the hanger and the pumps dropping off the bottom of this.
Right.
No surge protection, no active valves.
So the pumps are just in there, probably zip tied or something.
Look, maybe not zip tied. I got to give them a little bit of credit.
I mean, I zip tied.
Maybe yours are, but not having that bucket of the surge tank in the venturi system, you're exposing yourself to the fluid moving and not being contained in a bucket. So we keep ours at 2 because the more fuel pumps you want to place, and it's such a tight constraint, you're losing capacity as well. So you need to think about how much capacity you have in the surge tank, because a Walbro 460 displaces about 300 mil on average each pump. So you start with 1.7 liters or 2.5 liters and you're already down into very small numbers.
Right. What's going to be the next product that comes out what's the soonest product you guys have coming out?
Oh, there's 5. So Trackhawk, Mustang version 2 is coming out. The reason why there's a version 2 is version 1 was so complex from a manufacturing engineering perspective. We want to simplify it a bit, and we sold out. Everyone asks us we get daily messages for the Mustang, so that'll come out very soon, probably next 3 months. The Dodge Charger Challenger Hellcat, this stuff is coming out. Ford Supra, so the Supra MK4 and then a late model Australian Ford XR6 Turbo Ute has basically the same design.
Really?
Yeah, it's crazy.
What?
So an old school Supra, the same profile, the same height. The only differences are the fuel level senders.
Okay.
One's old school, one's new, but
Gotcha.
exact same profile in terms of the. Obviously, one has more outlets because for the emission system, but it'll be a modular system. So that'll come out. We've been developing that for a long time, but just getting access to Supras has been a bit difficult. So I think Supra owners will love that because the options available don't have a surge tank at the moment. There's no Venturi system that sort of keeps, again, everything contained, available to the fuel pumps. It has an active valve system. Yeah, and then the Supra MK5. And then after that, a lot of other projects we're looking at, like I said.
Right now, in America, how many of the top cars have your setups?
Oh, we have a lot. We've done a lot of cars. Like I said, Johnny's RX-7, Johnny Grumwald, which is the Pennzoil RX-7. That's our 5th or 6th project with Johnny. Johnny will reach out to us. Everyone reaches out to Johnny, and Johnny will reach out to us and say, Julian, I've got another car. Do the car. Look, there's.
How did market in contact with you guys? How did he know to?
Yeah, because look, I think we were. I'm going to say this, just be honest. We're an engineering company. We're not a marketing company.
Okay.
Americans market their products really well. It's sort of like robbing Peter to give to Paul. If we spend money on marketing, we can't spend money on engineering.
Right.
And I'd rather spend money on engineering than marketing and work word of mouth. So
that's
up
business
until
in general, though.
Yeah, up until now, it's been word of mouth. We have I think 65,000 people across all social media channels. Like Facebook, our Facebook's pretty big. It's like 56,000 or 53,000. So that's word of mouth. We'll do a project here and there. Someone will reach out to us.
Right.
But we have quite a few. I'd say hundreds of cars in the States. Customers are actually running, numbers.
Right.
So the quickest stock bottom Pontiac G8 in the US is Chris Merry. That's one of our projects. Drop-in system. He ran that number. He ran at 8.9 at 165 mile per hour for drop-in fuel pump module with a quarter of fuel tank capacity. Stock fuel lines. Yeah. Stock fuel line. That
matters. That fuel definitely matters.
Yeah, absolutely does. Susie, who runs the Chevy SS with the big AI, we ran a 9.1 in that. That has 8s in it as well. Again, that's all plug and play mil-spec wiring harness, uses factory fuel lines, module drops straight into the surge tank. And actually that's a big a funny thing as well. At Texas, a lot of cars weren't running too well because the fuel systems were having issues, and we were out every run.
Wow.
Yeah, so those are the sort of little wins for us.
Red Bull too, right? You said something about Red Bull you mentioned.
Yeah. Well, so back in the day, we did some projects with Red Bull in Japan. We did Kawato Sons. We don't work with them now. I can be honest about that. We'll ask for sponsorship, and we're not a company that has a sponsorship budget. So they were the first white, I want to say like the foreign team, because it's owned by Kawato and it was called Humble. And, the first foreign team ever to win the Formula Drift Japan Championship, the entire championship. So I designed the fuel system for that. Some of his Mad Mike, obviously. I designed his Rad Bull, which was the 1,080 horsepower quad, rotor twin turbo MX-5 with the sprint car chassis. I designed the fuel system for that. There's a lot of cars that we've done that I think a lot of the US audience wouldn't know that we did the fuel system for. Right. We have a dedicated fuel number for the US as well. I'm going to be based in New York again full time. Okay. So from a technical perspective, anybody can call me. Everything above 800 horsepower.
800 horsepower. Don't
Look,
call
if
them
it-
400 horsepower.
look, if you have the budget for 600 horsepower and above, because obviously the fuel system, look, a drop-in fuel system is about 2,500 US,
Yeah.
but it's complete. It's complete. And I just want to touch on that. We market our prices as a complete plug-and-play system. Now, we have competitors that market their prices lower, but then when you start to install things, that's when the prices start creeping up. Mil spec wiring, assembly, ours comes complete, fully assembled. The Chevy SS, the Camaro SS, all those kits, they're all 2,500. They're 2,485 US for a complete plug-and-play solution that you can install in less than 4 or 5 hours.
4 or 5 hours.
Yeah, and quicker, because obviously you have to drop the rear end.
Right.
But if you didn't have to drop the rear end, it's a 1.5 to 2 hour install.
Yeah.
So yeah, trying to make a name here, and we want to work with as many projects as possible. And again, they'll speak to me personally.
Right.
I have all the time in the world to speak to 100 customers a day about their fuel systems, because this is what we love.
You do?
Yeah, no.
Stay on the phone for like an hour just talking about different fuel setups and what's going on.
Yeah, we're going to be based in New York again, full time. Support number in the States. If you're a workshop, you're a tuner and you want to work with, people that take fuel systems very, very seriously, take technical support very seriously as well. Please reach out to us. We really want to grow the market here, because like you said, we're the incumbent in Australia. We work with many of the record holders, and they're not just Australian record holders, they're worldwide record holders.
Right.
Horsepower records, time attack, championships, track, you name it, in Europe, drag racing records, very, very hands-on. You can call us for the advice, and I will break it down. We will break it down exactly what you need and steer you in the right direction. So
tell the viewers and listeners where to find you, where they can contact you.
So aftermarket. So obviously we speak to our customers a lot through Instagram. So just Aftermarket Industries or Fueled by AI, but Aftermarket Industries is our international sort of page. They can visit aftermarketindustries.com or .com.au. We own the domains. There's a fuel system calculator there. So as a first step, if you're building anything, again, look, it can be 600, 400 horsepower. It doesn't matter. Generally those guys, won't want to spend that kind of money on a fuel system. But if it's anything serious, then please just fill out the fuel system calculator form. You don't need to speak to any of us directly. That'll come through to the entire team. I'll look at it, and then I'll give you a response. I'll point you in the right direction. I'll give you all these sort of ins and outs and nuances of what things to look out for. It's up to you whether you want to take that advice. We have an office on 30th as well, so we're right in Midtown.
Okay.
So yeah, just
that's where you'll be at?
Yeah, we've actually had that office for 4 years.
Oh wow.
Yeah. So dedicated number, dedicated US number. I'll be here full time, and then we'll be building a team, and we may branch out to Florida or Texas at some point. So it just depends where we want to go, because it's cold as hell in New York.
Yeah, New York is the weather is trash.
But look, that's what I want to say. Look, if you're looking at a serious fuel system and you're sick of watching your fuel level gauge, speak to us. We'll have a solution for you. And if you want us to design something that's custom, we do that as well. Obviously we have a team of engineers. We do a lot of custom work. Sadly, we can't share a lot of the custom work because it goes to, race teams or whatnot. We've done some crazy things in the UAE. Crazy projects that we just can't share. Yeah. I'm talking billet fuel tanks.
What?
Yeah.
Billet fuel tanks?
Yeah. Billet 2-piece fuel tanks.
I didn't even know that's a thing.
Yeah. And I'm talking about 60, 70 litre fuel tanks.
Wow.
Completely out of billet. Top piece, bottom piece.
That's crazy.
Yeah, injection molded O-ring. Yeah, we've done some crazy stuff that we can't share.
Well, you can share off camera, no?
Yeah,
no,
possible.
Okay. Well, I do want to say I appreciate you.
Thank you.
All the way from Australia. Really appreciate you. I know we're going to do some stuff tomorrow, which I'm excited for.
Yeah, and Texas.
And Texas 2K.
Yeah.
So you're going to be there for the whole week?
Yeah, we're going to be there for the whole week.
Yeah. So we'll be there on Sunday. By the time this comes out, Texas will probably be passed already.
The flights are crazy.
What do you mean?
From here to Texas, Fort Worth.
Yeah, it was literally like the price of going to Cali. You can go to Cali for the same price.
More expensive.
Right. Well, right now probably because of the week. Yeah. Are you going? What day are you going?
We're flying out, I think, on Sunday.
Oh, same thing. Yeah. I don't know.
Maybe we might catch a bus. You know what I mean? The bus is like $200. It's like $500.
Yeah, it was about $600 flight round trip.
Crazy.
Yeah.
I didn't get that.
You got to get out there early, and people book their homes like months in advance because the Airbnbs and they
Yeah, we got a hotel, so we're fine. Yeah.
Hotel's cool too, but even those book out if you're like a week out.
Yeah, really. No, yeah, we're lucky.
Do you know how far you are from the track?
16 miles.
Oh, that's pretty far. No, we're further away. Yeah, that's not bad.
Yeah, it's not too bad. And it was pretty cheap actually. It was I think for like the whole week, like 350 US.
Oh damn, you might.
Yeah.
Hopefully you're not staying in
I got an early.
La Quinta. La Quinta. That's Western.
We've been watching Serial Killer. You know, we've been preparing like on Netflix and stuff. So Richard Ramirez, you know, that kind of stuff. You know, Night Stalker.
We got a wet carpet.
LA had that vibe.
Did it?
Yeah, LA had that vibe.
Man,
especially our hotel.
Oh, if you stay in downtown, it probably does.
Yeah, it had that vibe. So I was in protection mode. But yeah, we'll be on the Super.
Yeah, we'll be spending the week pretty much tomorrow, and then we'll see you in Texas again.
Yeah.
But I appreciate you.
Thank
we
you.
got Dr. Fuel all the way from Australia. If you guys have any questions, or if you want to build your car over 800 horsepower, even if you have a 600 horsepower build, you guys can reach out to him. Thank you so much for coming out.
Appreciate it, man.
For those listening and watching, make sure you guys like, share, comment, and subscribe, and I will catch you guys on the next one. Also, cop some merch too. Peace.